Welcome to the video where I explain how my Autoadaptive Multi-Item Sorter really works. If you haven't seen my previous video, in which I explain why you should definitely build this crazy new storage system, then you may want to check this out first. So, the basic design is very simple. I first had the idea to build a sorting system like this in 1.6, I think, which is way back when hoppers were fairly new and sorting systems were the great new thing, but my redstone skill level was way too low, so it took me a long time, but now I finally finished it. But the basic design is still the same. So you put your item that you want to sort into this input chest, and it then gets automatically transferred into the hopper under your first storage chest. And in this storage chest, there are no diamonds, so obviously you don't want the diamond to go in here. And to test this hopper, which is filled by 4 renamed items and the diamond, so only diamonds or the renamed items can go in here. It is tested whether there are items in your chest. And no items are in there, no diamonds are in there, so no diamonds will go into this hopper. So now this diamond is transferred into the hopper under the next chest, and here are diamonds. So when you now flick this lever, there are now 2 diamonds, and the system recognizes that there are now 2 diamonds in here, so there must have been diamonds in the chest above, and it takes the 2 diamonds and puts them into this chest. Obviously, in real life it isn't that simple, because somehow you have to detect the number of diamonds in the hopper, and you have to transport the items into the next hopper or into the chest, depending on the number of items, and all of this gets complicated rather quickly. So there are a number of different problems that I show in this rule diagram, and the rule corners mean the following. So green is a pleasing result. Yellow is slightly inconvenient, so you can build it, but it's a little inconvenient. Orange is it's working, but it has some really annoying problems. And red is you can't use it at all. So my first design was like this. It's a big bit, but well, it was only a test. The main problem with this design is that it has no overflow protection. So when your chest is full, then obviously the one item that you took from the chest go back into the chest, but the other items, well, they can't go into the chest, so they block your system and it breaks, and that's really bad. So red for this one. Also, due to the kind of detection for the number of items that are in there, it only works with either 16 or 64, but not with both kinds of items. So you had to build some system in front of it that distinguishes between 16 and 64 stack type items. It works at a speed of 17 items a minute, which is quite great. It's way too big, to be sure, because that's only one double chest and you're using the space. But, well, who cares? It was a prototype. And when you're trying to use this, you have a clock that's always running, which produces very much noise and also might produce lag if you build a lot of them. So my next design was a bit smarter. Well, it was a first design that worked. So this was a really huge step for me. It was back in 1.8, I think. So it uses stack sizes 16 or 64 still, but it has an overflow protection, which means if the items can't go into this chest, they are just going on into the next chest. It works at a speed of 9 items a minute, which is half the speed of the previous design, which is, well, it isn't as nice, but it's okay. It's still quite big, and the next design won't be smaller. And it still has an always running clock, which produces dropper noise all around the time. so not that great. I tried to fix this hopper dropper clock issue in the next design, which thereby makes a green light at the no noise when not needed category, but unfortunately it gets even slower with 4.5 items a minute, which is quite bearable. So yes. Then a lot of time went on. I wanted to do a video on this one, but I didn't do it for various reasons. And a few months ago, I thought, well, now that I've built this printer design, why not try to revisit this project? And I managed to do it even smaller, even faster, almost perfect. So the new design allows all stack sizes. Of course, one means that there are unstackable items. They still cannot be sorted, but they won't break the system if you put them in there. The overflow protection has some problems in this design, but it's working, and I think it's not a major issue. The speed is 20 items a minute, which is faster than all previous designs, and of course it's slower than other sorting systems, so you could argue it's a yellow, but I think since it's used for rare items only, and you haven't got much of those items anyway, it doesn't really matter the speed, so I think it's green. And it's hardly smaller possible. So of course this is still a quite big design with a footprint of 10 by 2 for a single double chest, but I don't think it's possible to build it smaller. Well, not very much at least. And it has a clock on demand, so it's almost silent. So over here we got the essence of what I built over there, which is essentially this 2-byte module, which is over there again, which is the input module. And then every following two blocks are a repeating pattern with the chest. So we've got this one segment, which is the input module, and we got the storing modules, which you can repeat side by side. I'm going to explain the storage module first, because then it will be easier for you to understand the input module. The main idea here is that we have this hopper under the chest, as previously seen, and when we put an item into this hopper, then it will, you see, it takes one item from the chest above, but only if it works to take an item from the chest above, and then those items get sorted out. So what you see here is the orange circuit, which takes a hopper signal from this hopper as soon as you put the first item in. And this makes sure that with some delay, which you see over here at the blue side, this is the delay circuit, and the orange one is until here, it's just the signal from the comparator, which then runs into this light blue from the other side, and the orange essentially makes this like a sorting hopper, where if you put items in, it will let items go out until there's only the specific amount of items in there again. So in this case, the specific amount of items is 19 at the first slot and 3 others, so 22 in total. And when any items go in there, it will take them out eventually. But before the items are taken out again, I got this monostable circuit right here, which is the cyan rule, and this just goes into this block, which unlocks this hopper for a short amount of time, so it will allow items to go in. Then the sorting module kicks in and takes all the items out of this again, and all the items go into the dropper right here, and This is fired by a very neat little observer clock, because we are really limited on the possibilities of using redstone, because redstone would connect to the lines beneath and on the side and so on. So it's very nice to work with updates. In this case, this powered rails, which of course can't sit on glass. So if you have this like this, and then we cause it an update, it begins to flash. So we got essentially a observer clock, and we can lock this clock with a lever or another redstone signal. So this is essentially what's happening here. So this clock only fires when this torch was on, so when there were items in the hopper that got into this dropper, then it will release this powered block here, which will enable the clock and then put the items from the bottom up into this hopper over here. Then the items will go from this hopper into this dropper, which is besides the chest. And depending on the length of the pulse, which we determine with a pulse shortener here. So, for instance, if the pulse is short, then the pulse shortener will shorten it to a non-existent pulse, so it won't fire the dispenser. If it was a short pulse, which means that only one item was in the hopper at any time. And if it is a long pulse, which means there were two items, which means one item got from the chest into the hopper, then this will power this observer, which will fire twice, once for powering the ray and once for unpowering, and thereby allowing two items, which are essentially the two items that got from the chest down and the item we want to sort, to be dispensed from the dropper into our chest. One problem, while the items are in the dropper, we don't want them to be transported from this hopper into the next sorting module. So we need to lock this hopper. And because of some timing issues when we do this individually per module, those hoppers are actually synchronized through all of our modules. This is done through this redstone here, which powers this block and thereby locks this hopper, and it is powered through this green wool block by this repeater. So let me quickly demonstrate this. When I put wool in here, then it will let the wool cycle through and the wool will end up in this dropper, but it won't be dispensed into this chest. So when I now unlock this hopper, the wool will be transported through this hopper into the next sorting module. But when I do the same with a stone, then you will see that it gets into this dropper and it directly gets dispensed back into the chest. As I mentioned previously, there's a little flaw with the overflow system. Normally, you can use the system while it is running and sorting, but if the system is almost full, you may run into this problem that when you sort an item that is in the system, then it takes out the system item from the chest, and then you fill up the chest completely. And now the item won't be able to get back into the chest, so there will be two items in this dropper. But since the hopper will only allow one item to go through every clock cycle, there will be one item too much in this dropper. And when the next item comes in, then one of the two items will stay in the dropper, and so on. And when you then happen to take an item out of here, so a free slot is created, then an item that is here but doesn't belong into this chest may get into this chest. This issue will not propagate to the modules besides, so they will work perfectly fine. And it will fix itself once your input chest is empty. So when no item comes in from the left, then an item will be able to go out and your system is fixed again. So it is very unlikely that it will run into this issue, but when it happens, just take the wrong item out from your chest and you're fine. now to the input module. At the top here, we got exactly the same method as for this hopper here with the green line. So it makes sure that also into the first module, the items get at the right timing. And from this chest, which is our input chest. And you could hook this up to anything else. So if you extend this hopper line somewhere else to some previous sorting system, like the impulse SB sorting system I did over there, then you can get your items from there. And also from the output, from the last sorting module, you can take this hopper line and put it somewhere, wherever you want. So what we need to do is power and unpower this green line in cyclic behavior. So here the red blocks, this is our main clock, which makes sure that there is an item dispensed every, I think, 15 game ticks. And it is connected to an rising edge monostable circuit. So this line only gets turned off for enough time for one item to get through the hoppers. So every cycle one item will go from one module to the next module. But obviously we don't want this clock to run all the time. So I put this circuit here at the bottom in, which stops the clock when it has run a certain amount of times, which is 8, I think. So after 8 times the clock runs, it will increase this counter here on this side and decrease it on this side. This is a nice little counter design which uses comparators. So the idea is that you have two comparators in subtraction mode which point into each other. I can quickly build this one over here. You build it like this, and what's happening here is that you have a signal from this one, and you have a signal from this one, and you have 15 from the input from the behind. So you subtract 0 from 15, which is 15, and 15 from 15, which is 0 again. But when you lower this signal for a short amount of time to like 14, then it will be 14 here, then it will be 1 here, then it will be 13 here, and 2 there, and then it will be 12 and 3, and it will go all the way until it switched sides and there's 15 here and 0 here. So this is the counter circuit. Let me demonstrate this. It's like you're having a lever there, like this, and you activate it. Now when you activate this one, it slowly decreases until it gets 0. And there's another level like here, which represents the clock cycles. So that's what's going on here. And this timer circuit gets reset every time something happens at this circuit. So we got this observer here, which observes this redstone, which gets powered by this torch, which will essentially power the observer when this module sorts something. And those modules, when they chain together, like over here, you see that the signal gets propagated. So when something happens here, the signal goes all the way back to the first module, which is the clock module. And here it goes into this circuit, which starts to resets the clock timer, so the clock will run for a little while more. To start the whole thing, it needs to recognize that an item got into the system. So I got this comparator here that takes a signal from the first hopper that really points into the system, and it will just, through this observers, power this redstone as well. So let me quickly demonstrate this. If I put an item into this chest over here, then it will power this comparator, which will power this redstone down here, which will activate our clock. And every clock cycle, this dropper will be activated, which pushes an item over into this hopper, which pushes back, but it slightly decreases the signal strength that the comparator gets from this hopper for a short amount of time. And in this time, our counter is decreased for a little bit. So now you see it stopped. And we can demonstrate this again by putting this on. And you see that the signal gets lower a little bit. But if something happens in the sorting module, it gets reset and it goes on. So this way, it is made sure that all the sorting modules got a clock signal until every items are through the complete system and out of it again. As you can see, the system works in 1.12 pre-release of Minecraft, and I also made sure while building this not to rely on subtick update order or quasi-connectivity, so I'm pretty confident that it will work in future Minecraft versions, and maybe it will also work in Pocket Edition, but don't quote me on that. I also tested the design in all 4 directions, so you can be sure it doesn't matter in which direction you build it. That's not a thing with the previous designs, but this one works in all 4 directions. So I said I would be talking a little bit about this design front here. Well, I needed an example for a system like this, and I didn't want to go on YouTube and just rebuild one, so I decided to build my own. And then I figured out it isn't that easy after all, because you have to somehow power all those layers of hoppers independently, and you can't easily get the signal there. But if you build a big wall of whatever and you get the torches on there, then you can at least lock the hoppers. But now you need a way to power those torches. One way that I found to power those blocks was using tripwires, because tripwires can power the block without powering the block beneath and above, and they can be put directly above each other. So now I only needed a way to power those tripwires, and first I thought about just dropping some items, but unfortunately items drop too fast, and the next thing that came to my mind were chickens. So I put a bunch of dispensers up here with spawn chicken eggs, but of course you can use normal eggs as well. It will just need even more eggs and work even worse, but well, who cares? And yeah, if you got a ridiculously big chicken farm, then that's the thing you can do. The other idea I had was reusing the chickens. So when the chicken got down, I would transport it over and back up and reuse the chicken. But I didn't quite manage to get it to work. So for now it's just this design, and if you got a ridiculously big egg farm, you can just put normal eggs in here and you have a working chicken-based sorting system. And you can even use the chickens once they are down here. You can put them in a normal water stream and do whatever you do with a billion of chickens. Yeah. So that's it. Thanks for watching. Don't forget to like, subscribe, whatever you do. Comment. We're very nice if people comment, because, well, likes are just numbers, but comments really make my day. So thanks for that. Bye bye. Also, there's a link to the world download down in the description.